And hello, everybody. You're very welcome to a new episode of Redefining Cybersecurity here on ITSP Magazine. This is the host, Sean Martin, where I get to talk to, as you know, all kinds of cool people about cool things. And this conversation is with Fahad Mughal. Fahad, thanks for joining me.
Thank you, Sean. Thank you for having me on the podcast.
This is going to be good. We connected, I don't know, a couple months back, maybe something like that. I saw you're
Yeah,
in the rail space
yeah,
and
yeah, yeah.
looking at OT and security. I'm like, we got to have a chat, my friend. Let's
Uh,
have a chat. So I'm thrilled you accepted my invitation, and I'm happy to have this conversation with you today.
Great. Thank you again for having me on the podcast, Sean. It's truly a pleasure to be here today. Let me start by saying that I am a regular viewer of your podcasts, and the work you
Thank you.
guys are doing to raise awareness about cybersecurity is commendable. So, I guess let me share a bit about myself.
Yeah, that's a good
I
place to start.
began, yeah. So, see, I began my cybersecurity journey in the banking and financial sector, working with some of the well known institutions in the industry. As your viewers and listeners might know, the financial sector is one of the most heavily regulated industries with a strong emphasis on cybersecurity. So, during my time there, I had the opportunity to work on and implement some cutting edge security technologies, focusing on areas like security architecture, design, conducting risk assessments. There was a phase in my career where I was deeply immersed in offensive security as well, engaging in penetration testing and red teaming exercises. Uh, this financial industry experience gave me a holistic understanding of both the offensive and the defensive sides of cybersecurity. Uh, I believe this dual perspective is an essential hallmark for a security architect. It's critical to think like an adversary when designing systems to protect them. So, fast forward to the past 7 years, I've been working with various critical infrastructure sectors like water utility and transportation, industries that rely heavily on operational technology or OT and industrial automation and control systems or IACS, as we commonly call it in our line of work. Now, this is where my journey into the OT cybersecurity space truly began, with emphasis on OT security architecture. Um, I got opportunities to work on OT cyber uplift programs of work involving design and implementation of OT threat monitoring solutions, architecting OT network segmentation schemes, leading the design of SOC environments, which are the Security Operations Center, with focus on security threat intelligence, monitoring and response, developing roadmaps for threat detection use cases using the MITRE Enterprise and ICS attack framework. So, one thing I quickly realized while working with and learning from engineers and relevant stakeholders in this specific industry is the distinct challenges and priorities of OT environments. Unlike traditional IT environments, where the focus is primarily on the CIA triad, which we call, the confidentiality, integrity, and availability, in OT environments, the the priorities shift dramatically, right? The focus here is on reliability, availability, public safety, as these OT systems control the technologies that influence and manipulate physical processes in the real world, right? So it was during this time that I gained an understanding and discovered my passion for railway cybersecurity.
Straight to the rails from water. I want
Yeah.
to, because an interesting transition, and I've not done much with OT. I've done a lot in traditional IT, and my sense is, while there are certainly different business operations, every business has different objectives, and therefore you select technologies to help you achieve them. Um, the general infrastructure of IT is fairly common, whether you're at a bank or retail or I don't know, a doctor's office in healthcare. Now you start to when you obviously you move into healthcare, you start to look at you have connections in OT and you have manufacturing, you have connections in OT, but there's still an IT role in each of those businesses as well. So my question to you, because I'm curious, is what are some of the differences in terms of how the technology is architected, how it's managed, IT versus OT, and when we start to dig into the vulnerabilities and the threats that look to expose them or yeah compromise them, exploit them, I should say. How are those teams and that kind of that whole environment and process and ecosystem and culture? How do they compare based on your previous experience in IT? Long-winded question
Sure.
there.
Yeah. So, yeah, interesting. As you mentioned, basically, if you consider just the railway industry, right? The specific sector, just like any other critical infrastructure sector, you will have the IT side of the world and you will have the OT side of the world as well, right? And so, if you take a step back and look at how the railway industry has evolved over the years, right? From steam powered locomotives in the 19th century to the electric and diesel powered trains of the 20th century. Uh, Railways have been at the cornerstone of technological innovation. So, today, we are witnessing the next big leap with the rise of autonomous and unmanned railways, right? We call it driverless railways as well. These modern rail systems use state of the art technologies to improve efficiency, reduce human error, and enhance passenger experience. Now, here's the flip side to it, right? As railways become more advanced, they also become more dependent on digital systems, right? And this is where the operational technology or OT plays a critical role. Now, OT systems in railways are the technologies that manage and control physical railway operations, ensuring everything runs smoothly and safely. So back to your question now, you you might ask, okay, what does OT encompass in a railway system? So let's try to break it down right now. Uh, First and foremost, you have the signaling systems. Now, signaling systems are like the traffic lights of the railway world. They ensure that trains don't collide by managing the track occupancy, guiding trains, and maintaining safe distances between them. In autonomous railways, signaling systems are heavily digitized and integrated with control centers to provide real-time data feeds, basically. So,
And can I ask
example,
you something here? Because
yeah,
as you said, the signaling look is kind of like the traffic lights. Um, the the other thing I was thinking, kind of the FAA. Is there an entity that oversees all of the signals, or is it by I don't know shipping signals versus or cargo transport and versus transportation? I don't know. Can you kind of paint that picture? Who has access to what data? Who's generating the data? Who,
yeah.
you
So
get that
so
kind of that
normally
view?
what you'll see in the railway environments is the railway entity actually controls those specific signals, right? So those data feeds are basically going back to the control centers, basically, or operational centers uh, that are controlled by the railway entity itself. So it would be the railway operator or the maintainer itself,
So
right?
this is the
And
physical rails on the ground,
correct.
regardless of what kind of vehicle is sitting on top of it.
That's true. That's true.
Okay, got it. Got it.
So, and again, this is where the signaling systems basically that are implemented in that railway infrastructure, that those signaling systems play a key role here. Now, uh, Examples of signaling systems would include CBTC, which are communication based train control systems, which are designed for urban rail systems like metros and light rails, basically. And the other example would be ERTMS, which is an European Rail Train Management System, which is designed predominantly for long distance and regional trains. So it's sort of the backbone of the entire railway infrastructure itself. Uh, then you have the interlocking systems. uh, these interlocking systems, think of them as the gatekeepers, right? They control the switches and signals, ensuring that the trains move only when it's safe to do so, right? So with modern railways, these systems are no longer mechanical. They are now digitized and connected, making them faster and more efficient. uh, then you have these onboard OT systems itself, on the uh, uh, on the systems, basically, which include technologies like automatic train control system, which governs the speed and ensures compliance with the signaling instructions. In autonomous railways, now these systems go a step further, managing the train's operations with minimal human intervention, right? So then you have the trackside equipments. Now, these include sensors, switches, actuators that gather data from the physical environment and communicate it back to the control system. So, for example, you'll have axle controllers on the trackside. Right now, these axle controllers basically help determine the track occupancy for the trains, basically, right? And then you have point machines. Now, these equipments would ensure that they manage the track switches itself, right? um, then you have SCADA systems in play as well. SCADA, which stands for supervisory control and data acquisition systems. They monitor and control the entire railway infrastructure. They gather the data from the field, like temperature, speed, equipment status, and provide operators with the information they need to make decisions in real time. Uh, and then you have these safety critical systems as well. Now, these are sort of the backbone of the railway operations. They're designed to prevent catastrophic failures and ensure passenger safety. These include automatic train protection, train braking systems, fail safe signaling mechanisms. Now, these systems are engineered with redundancy and strict compliance to safety standards, right? Ensuring that even in the event of a fault, the system defaults to a safe state. So these would be, the main categories of, uh, you know, uh, operational technology systems that are prevalent in, railway infrastructures. And with the advent of autonomous and unmanned railways, OT systems have become even more interconnected and data driven. Train communicates with the control centers. They communicate with trackside equipment. They communicate with other trains in some parts of the world. So trains communicating with the other trains to optimize the schedules and ensure safety. Uh,
Yeah, there was an airline situation here. I think it was in, I can't remember where it was in the States, but Chicago perhaps. I don't remember. But anyway, two planes came very close to each other, and as the story goes, the two planes knew. One plane knew, well, each plane knew of the other one that they were in imminent danger, and one was automatically guided up, the other was guided down and maybe away from each other. But so
okay. Yeah.
the story goes, the planes detected the peril and
Right.
adjusted their flight path automatically to avoid collision, which it was pretty cool. Sounds like some of that same type of analysis and capabilities there for the safety. Maybe can you, using that and maybe other examples, kind of provide a view of what some of the objectives are for the railway environment. I think you mentioned speed and efficiency and things like that. What are railway companies trying to do? I don't know. And how does the railway system? Do they support those objectives? Or do they have their own that compete against carriers and, and transporters?
Yeah. So the see from cyber's perspective, right? The main objectives of the railway systems would be to ensure the reliability, of the operations itself, uh, availability, of the environment, maintainability, and safety. Now, these are some of the major components basically that make of uh, the main objectives basically of the entire railway operations itself, right? You know, as you said, these integrations and sensors basically, they bring incredible efficiency. When you see the railway operations work, but it also
I'm
significant.
curious. I'm curious.
Yeah.
Are they trying to push the trains to go faster while maintaining safety? Are they trying to put more trains on the tracks and trying to manage the schedules in order to deliver more people and goods? I don't know what some of those things, and because when we start talking about the threats, right? If that gets really complex because they're pushing the envelope on what they're trying to achieve and pushing the envelope of the technologies that enable them to do that, those are prime target points, in my opinion, for the availability and reliability things that we're trying to achieve, right?
That is very true, and I guess it will depend on which part of the world you are in. I guess, right? Because in some parts of the world, uh, they would like to increase how many people travel on the transportation systems each day, and they would try to increase the capacity. uh, but then there are some parts of the world that are competing to have fast metro lines basically, high speed rails basically, going from one point to another. So uh, yeah, I guess it depends on what part of the world you are in basically, and depending on that, you would see basically the priorities would change, I guess.
Yeah, absolutely. And it's always interesting when you throw that depends thing in there, because then you have different scenarios and situations you have to be prepared for, which
That's
means
true.
tuning the technology and looking for different threats. What maybe we can talk a bit about. I don't know. Do we cover enough of what's in it and what they're trying to accomplish? Are there any other points you want to make in terms of what it looks like to kind of help
Yeah.
frame where the weak points might exist from a cyber perspective?
Yeah. So I guess as I was saying, when we look at these specific technologies, and the integration that they bring about, right? And with these specific integrations, they bring about incredible efficiency as well. But it also then significantly increases the attack surface for cyber threats, right? As you do more integration, as you make it more digitized, more IT/OT integration, the attack surface uh, definitely sort of then it increases the cyber threats. uh, Now, if we look in the past decade, for example, right? And if we look at some of the significant incidents, cyber incidents that have occurred in the railway industry, right? They highlight unique challenges that railways face when it comes to cybersecurity. So, for instance, in 2023, uh, Poland uh, had an incident. Now, it was attributed to a nation state actor. I guess all of us can understand basically with the geopolitical situation in that part of the world.
Yep.
But in 2023, adversaries exploited vulnerabilities in the radio communication system that was used by Polish railways to issue unauthorized stop commands, triggering emergency brakes on multiple trains. So the adversaries in this instance used a simple unencrypted radio frequency to send commands to trains onboard systems, exploiting the lack of security in the communication protocol. Right.
Sounds like an authentication issue.
That's true. Yes,
Yeah.
yes. So the impact of this particular incident was that the trains across Poland came to a halt, leading to operational chaos. Freight services were disrupted, impacting supply chains, uh, while passengers were stranded, and they faced enormous delays basically. Now, this attack revealed a critical gap in the cybersecurity of using legacy communication systems in the OT environments that rely on outdated protocols. And as you said, basically one of the lessons learned from this particular incident was the use of encryption and authentication, right, that must be implemented across all communication systems, including the radio protocols itself. uh, so now this is sort of one sort of incident which directly affected the communication system, leading to trains halting, right. The other incident which happened in 2021, which happened to Iran's railway network basically. And in this particular instance, adversaries targeted Iran's railway infrastructure, breaching scheduling systems and the digital message board systems that you see, normally at the train stations. Now, uh, the modus operandi of in this case was that the adversaries compromised the scheduling systems, which sort of lies in the IT side of the railway infrastructure, right? But it does interact with the OT environment, because you get the information out from the OT environment into the IT, and the scheduling systems sort of work from there. Now, in this specific case, while the safety critical OT systems were not directly affected, but the attack exploited indirect vulnerabilities in the IT to OT interface, right? The impact in this particular instance was that passengers were misinformed, leading to widespread confusion. Digital boards displayed prank messages. It tarnished the public trust in the railway authority there, basically, right? Uh, the incident, uh, highlighted the risk of poorly segmented IT and OT environments in this case. And one of the lessons learned from this particular incident was that even indirect attacks on IT systems can cripple the OT operations through disruption of the public facing or planning system that are used in the railways. Uh, the the third uh, case study that we can look at was in San Francisco. Actually, it happened to the San Francisco Municipal Transportation Agency
Yeah,
in
I was just looking
2016.
at it was Bart. I think it was the ransomware case, right?
Yes,
Yes.
yes.
Yeah.
So as you might already be aware, the San Francisco Municipal Transportation Agency, it's responsible for both the trains and the bus networks, basically, right? Now, it suffered a major ransomware attack that disrupted the ticketing and the scheduling systems back in 2016. Now, the ransomware infiltrated the backend systems responsible for coordinating the train operations and public information. The impact in this case was that the fare systems were rendered inoperable, and leading to free rides for passengers during the weekend, and there were operational delays which disrupted the train scheduling and coordination. Although in this case as well, there was no safety critical OT systems that were compromised, but the incident showcased how the breaches on the IT side can indirectly affect the OT operations, right? So when we look at these particular case studies, right, there are other numerous incidents, but I just took these three for the past decade, because these three sort of showcase different sort of modus operandi and how they can sort of affect the railway operations, right? uh, Now, while these case studies highlight the vulnerabilities that can be exploited in railway systems, leading from IT cascading into the crippling of the OT operations, it's worth noting that till date, uh, the industry has been relatively fortunate in avoiding any large scale OT consequences, from cyber threats leading to any safety compromise, right? Uh, in my humble opinion, this is due to several factors that make direct attacks on the railway OT systems less frequent. Uh, the first factor is the use of legacy systems. Now, many railway OT systems still today still rely on proprietary or air gap technologies like relay-based interlocking systems uh, that were not originally designed for connectivity, making them harder to target remotely. Right?
Yeah, all the SCADA stuff.
Yeah. So, although SCADA is becoming very interconnected and stuff, but there are some technologies that are still utilized within the railway environments uh, that you can't sort of target remotely, basically, right? uh,
Now, is that a lot of, because I'm picturing railway systems that have been around for maybe hundreds of years, right?
True,
That are
true, yeah, yeah.
they're there in their physical state. Now you're trying to tack on and connect digital systems and sensors and
That's true,
controllers on
that's
that
true.
stuff, right?
Because yes, because that sort of provides the pathways, right? Remote connectivity pathways, basically, from the operator stations to centralized control systems to the particular PLCs, basically, right? As you become more connected, basically, it provides pathways to adversaries as well, right? To issue commands. Uh, but when you're using those legacy systems, basically those pathways don't necessarily exist, basically. So
Can I
that's
ask you something about response? And hopefully I'm not derailing, pun intended, derailing you too much here, but because that example of the signal being sent to, or the encrypted command being sent to stop a bunch of trains and trigger their brakes to activate. Um, I don't. Who's looking after that? I mean, because that to me that's an anomaly, right? If multiple trains all have a signal that say halt your brakes, that's an anomaly in the communications environment. So you mentioned the SOC earlier, the Security Operations Center. Is there a railway SOC? Does each train operator have their own SOC looking at this stuff as well? Because I'm trying to figure out who's responsible, who's looking, what are they looking for. Does everybody have this use case in their playbook now for detection and response?
Yes, yes.
Can you kind of paint that picture?
Yes, I'm sure after that, yes, many of the SOCs would have implemented such scenarios. In the specific case of the Poland railway attack, that was more of a backup pathway, basically. That was actually, so that's not
Okay. So subverted traditional
that's
or
the yeah.
the core
So
system.
that's not the the primary pathway to issue commands, but it's sort of used when you want to pursue a backup pathway to issue emergency brakes, and that was something that the adversaries sort of exploited, right? And much of the knowledge of this we can sort of consider uh, it requires a lot of research to understand basically how the railway systems work, how you would issue such commands. And of course, when we look at the nation state actors these days, basically uh, those are the actors basically that will have the enough capability and understanding of how these systems operate and how you can issue such commands. uh, Primarily, the the railway operators would be the ones basically looking at these functionalities, depending on how mature your SOC is and how much your SOC is actually integrated with the day-to-day railway operations, and how much they understand the railway operations. These threat detection use cases you know uh, would only be developed when you have the understanding of how these systems sort of function together. So I guess that might answer your question there. So it
That's
depends on the
a
maturity of the SOC, I guess.
Yeah, well, it's a super important point in my view that yeah, you can identify weaknesses all day and all night, and yes, you might be able to hypothesize how they might be exploited to do something. But to your point, if you have an understanding of how the system works, you can use one or more legitimate actions with
That is
maybe
true.
one illegitimate
That
nefarious
is true.
action in
That is
there,
true.
and if you're not expecting that nefarious one in there, you might
That
not catch it.
Yep. That is true. And you guys, from that perspective, it's important to always sort of look at the baseline. There are OT threat monitoring solutions that are sort of ingrained in the environment these days. And some of the solutions that I have seen understand the signaling protocols as well, because they're not like the normal network protocols that we used that we use in our data centers. Now these threat monitoring solutions basically understand the signaling protocols, how they work. They can look for anomalies, and these sort of solutions act as one of the primary input into the SOC environments, so that you develop a baseline, basically understand basically, okay, uh, what normal looks like, and then basically if any anomaly occurs, then that should alert the SOC operators or the rail operators itself. um,
So on
so
that point, how important is it that a human? I mean, obviously the trend is moving to autonomous vehicles, if you will, right? The trains will be autonomous. But from an operational perspective, how important, and maybe even on the train still, how important is it that there's a human involved?
see, the human involvement is always there at the back end, right? Although the newer driverless trains basically, or the autonomous trains, they sort of function in an automated manner, with all the controls basically, from the automatic train control systems, connecting back to the control centers basically. And uh, and all these mechanisms around the safety protocols uh, that reside there. Now, one thing to understand here is that railways have stringent safety engineering mechanisms in play as well. So we need to sort of acknowledge that, right? Now, these systems are designed to prevent catastrophic failures. For example, if you look at the interlocking systems, they have multiple layers of safeguards, right? And components like signaling networks are designed with built-in redundancies as well, such as duplicated controllers, parallel communication channels, to ensure continuous operations. Now, railway systems do prioritize fail-safe principles, where systems default to the safest state, for example, stopping the trains in case of failures or anomalies. So safety, plays a, a key role there. And all these systems are engineered in such a way basically that the safety does take priority when an event or a failure occurs. uh, But having said that, as railways do continue to digitize and integrate IT with OT, the attack surface is rapidly expanding. This opens the door for more sophisticated threat actors, including nation state groups, to target railway systems as part of geopolitical conflict, as I mentioned earlier. Right now, for example, disrupting a country's railways could cripple supply chains, passenger transit, creating both economic and political chaos. So, you know, while still till date we may not have yet seen any widespread direct OT consequences or direct attack on the OT systems in the railway sector, but the risks are growing with the changing threat landscape, right? So it's only a matter of time, as I say, that the right combination of opportunity, motive, and capability brings these threats to the forefront, right?
Yeah.
Uh,
Yeah.
so yeah, so this is where I see the current state of cybersecurity,
Yeah.
where it's at, within the context of the railways.
One of the things I'm hoping to talk quite a bit about this year on the show is the supply chain and interconnectivity. Um, look at look at New York subway. It's pretty much an isolated system, right? But if you go to Sydney, where you are, or San Francisco, the rails cross uh, car and truck vehicle systems. So there's coordination between rail signaling and automobile signal and pedestrian signaling as well, right? In some cases, pedestrians get to go first. Um, so that just opens my mind to, I mean, the rail systems aren't the only places that innovation is taking place. There's in the autonomous cars, right? But then also smart cities, the bigger picture there. So I'm just wondering, everything, not just everything in rail, but everything is connecting, and then there you have all these parts. So it's another big question. But your view on how supply chain is viewed within rail, within itself, and then also from a connected perspective to other systems, not just IT for the rail operator, but like cities and cars and things like that.
Yeah, so see, from the perspective of supply chain, it is one of the hot topics within the risk management framework of enterprises, basically, right? uh, and in this specific case as well, yeah, when you look at uh, any standard, for instance, any international standard, it will call about supply chain security as well. And similarly, this is also a very prevalent threat in the railway industry sector as well, basically, right? uh, Now, you know it, organizations, as I see, are ensuring that they have the right sort of risk management frameworks, right sort of policies, basically, in place uh, to address this specific threat of the supply chain, because you need to have a good vetting of the vendors, basically, that you are taking your components from. You know uh, this this sort of requires uh, you know mature risk management practices within the enterprise, and how they sort of use it. And I guess in this instance as well, every organization is sort of different, from maturity level where they are at, how stringent their risk management practices are, with regards to supply chain. uh, Having said that, when we look at uh, any international standard, basically, that's being globally used for railway industry as well, one of the primary component is the supply chain security there. that is being called out basically.
I think you touched early on. You touched on some of the standards. I think there are operating standards. Are there also specific cyber standards for railway that you're seeing? And are there, if you want to list any that are of interest?
Yeah, so see, there are several internationally recognized standards and frameworks which we normally use in the IT side of the world, like NIST-CSF, for instance, that serves as a foundation for building resilient, infrastructures, or ISO 27001, which again, which helps develops the ISMS for the IT side of the
Right.
railway infrastructure. For example, to secure IT systems like ticketing, passenger information, and operational data centers,
Right.
right? But then there are certain standards that are applicable to the railways OT environment. Um, so first and foremost, basically, there is IEC 62443. Now, this particular standard, it's a globally recognized standard for securing industrial automation and control systems. It's not specific to railways, but it's designed to address cybersecurity across a variety of industrial sectors that use operational technology or industrial automation and control systems, including the OT, systems in railways. So it's applicable to railway systems as well. It provides a comprehensive vendor neutral set of practices applicable to the entire life cycle of OT systems, right? You know, Ensuring cybersecurity is in place from system design to procurement, deployment, operations to maintenance and decommissioning, basically. And this is where as you're mentioning around the supply chain factor as well. It comes into play in the entire life cycle. When you're sort of purchasing any new components. Now, this specific standard, it sort of introduces concepts of segmenting systems into zones based on criticality of the systems, and defining conduits between these zones to securely manage the communication pathways basically between these zones. Uh, it also introduces some concepts of security levels based on the threats faced to a particular zone, uh, the protections that are required for a particular zone, and the criticality of the systems that are residing in a particular zone. It provides a structured approach for identifying, assessing, and mitigating risks. This includes, security policies, vulnerability assessments, and incident response planning. Now, it is applicable. Now, this standard, as I mentioned, it's a globally renowned framework and standard that's used across multiple critical infrastructure industries. Uh, in context of railways, it's applicable to OT systems like signaling, SCADA, interlocking, ensuring they are resilient to cyber threats. So this one is particularly a global standard. Now, the second standard, which is sort of customized towards railway industries, the TS 50701. It's an European standard. It's basically a technical specification um, specifically designed for cybersecurity in railway applications. It provides a detailed framework tailored to address the unique challenges and complexities of securing operational technology systems in railways. This TS 50701 builds on the principles of 62443, the standard that I mentioned earlier, right? So they're very intertwined basically, but the 50701 standard is customized for railway specific needs, right? It sort of introduces the same concepts of zones, conduits, security levels, but it looks at them in the context of railway systems basically, okay, and how you can actually segment the different railway components into different zones. So for instance, protecting the highly critical systems like signaling or interlocking and isolating them from less critical or more exposed systems like the passenger information systems. So it this particular standard, it provides very actionable guidelines for railway operators, maintainers, manufacturers, even the vendors that build components for the railway systems itself. Now, uh, TS 50701 is often used in Europe to guide the design of secure signaling systems and interlocking systems. Um, the, the third particular standard that I touch upon is um, a RAMS standard. It stands for reliability, availability, maintainability, and safety. It's EN 50126. Now, this one is not a particular cyber standard, but sort of a safety standard, which is highly used in this particular industry. It's again, it's an European standard that establishes a framework basically for safety in railway systems. It defines a very structured life cycle process to ensure safe and dependable operation of railway assets while addressing the unique challenges of safety critical systems. uh, it introduces concepts of methodologies for analyzing potential failures and their impacts on operational safety and performance. It introduces concepts of safety integrity levels to quantify the risk reduction required for safety critical functions. um, as I mentioned earlier, it's not a particular cyber standard, but it does acknowledge the increasing overlap between functional safety, which looks at preventing physical harm, and cybersecurity, which looks at protecting against malicious actions, basically, right? So this particular standard is widely used for developing safety critical systems like automatic train protection systems. So yeah, these would be, I guess, uh, the main standards that are sort of used globally. There might be other standards out there as well, but I've seen these standards being used and referenced you know uh, uh, globally a lot, I would say.
Yeah, that's a fantastic overview of those. And yeah, so I think we can point people to them and they can explore them. And of course, if anybody's listening or watching, they want to comment on others they see that are helpful, I would encourage that. I don't want to stop, but we're approaching 50 minutes. So I have a gazillion questions still. So maybe, I don't know, maybe we can have another chat down the line and dig into some more
Sure,
things.
sure, anytime.
I want to leave my audience, a lot of security leaders, CISOs, managers listen to my show. Maybe maybe a final thought from you with them in mind, something they can take away, something they may not have thought of or should be paying attention to because of what's coming. Yeah, final thought from you for that group.
Yeah, I guess when we talk about the railway industry itself, it sort of stands at the crossroads of technological innovation at one hand and the rising cybersecurity challenges, right? As we move towards more smarter, connected, and autonomous railways, which are being adopted globally now, the the need for robust cybersecurity, I guess, has never been greater, right? Uh, Particular industry standards, like I just mentioned, around TS 50701 and IEC 62443, they serve as good foundations for building secure systems in railways. While collaboration, industry collaboration, interdisciplinary collaboration and innovation will drive resilience, right? I guess that is a very important aspect, basically, that a lot of organizations miss, because what we see today is, you know we have these engineers that understand the intricate details of the systems itself, right? The dependencies of the systems. But on the other hand, you have these cybersecurity experts, right, we need them to be talking more, basically, so that we can design, and protect these systems, because the engineers understand the system dependencies, and the cybersecurity experts understand how adversaries infiltrate, or could potentially infiltrate, these systems itself. So there's a lot of collaboration needed, basically, in that space. And coming back to what I was saying around the OT consequences, basically, that we haven't seen it yet. The question isn't if railways will face cyber threats with OT consequences. The question is when, basically, it's going to occur at some point in time, and I guess,
Yeah,
we sort of need to be ready, when that occurs. So yeah, I
yeah.
guess that's my final thoughts
No,
on,
I love it.
on
Yeah,
this subject.
we've seen the signals for what can happen, and yeah, I think I'm hopeful because from an enterprise perspective, there's a lot of momentum from from the resilience perspective, business resilience, IT resilience. I'm hopeful that we'll see a lot of that push into, or OT ask for help with that for OT resilience as well. But the other thing that I always, any conversation that involves OT, whether it be in water and power, or rail, or transportation, or manufacturing, safety is always a big thing. And I think when we talk about cybersecurity and we try to connect it to people, we end up landing in healthcare, which of course has some OT in there as well. And then we talk about ICS differently, separately, which has OT. And I think we forget that just the operations of this, the safety of the people operating it, and then the safety of the people enjoying the spoils of whatever that service is offering, being getting from A to B, or clean water, or power, or gas, or whatever it is. The people around it need safety as well. So safety is always another big thing. So I'm glad we had a chance to talk about that as well. And yeah, I'm super happy we had a chance to talk about this too, Fahad. Overall railway security, great overview, great conversation. I hope you'll join
Thanks
me
so much,
again.
Sean. Yes,
Lots
definitely.
more to dig into.
Thanks for having me here. Thanks a lot, Sean. Really
Thank you.
enjoyed it.
And everybody listening, watching, thanks for joining us for this chat. And we'll include some links to some of the standards and frameworks and things that Fahad mentioned. And of course, please do share with your friends and enemies, and stay tuned for more here on Redefining Cybersecurity on ITSP Magazine. Thanks, everybody.
Thanks all.